Okay, here's your review for the definition of the derivative test coming up. Well, I'll say quiz, not test. It's pretty straightforward. Okay, number one, write off your note cards, the definition of a derivative using the limit. That's that. The derivative, which we say as f prime of x, equals, it's the limit as delta x goes to 0 of, it's f of x plus delta x minus f of x all over delta x. Change in y over the change in x. What we need to be looking at. Okay, number two, difference between a secant line and a tangent line. For a secant line, that's a secant line hits the graph at 2 points, whereas a tangent line hits the curve at 1 point. So if this is my curve, that right there would be a secant line. This right here would be a tangent line, touching at 1 point versus touching at 2 points. Next question, why is the derivative of a constant function equal to 0? Well, if I draw a constant function, what that means is I have just a straight line. Derivative means slope. What is the slope of that line? That slope there is 0. So that's why the constant function's derivative, its slope is always 0. And a derivative gives you always the exact slope of the tangent line at a given point. We don't want to approximate it. That's what a secant line is for. We want to know the exact slope. Okay, let's actually go and find these derivatives now. This is using the definition of the derivative. Using the definition of a derivative. So that does not mean you can use the shortcut. You'll be able to do that later. You can't here. So for this one, it's going to be f prime of x is equal to the limit as delta x approaches 0, f of x plus delta x minus f of x all over that change in x delta x. That's what we should be looking at first. I'm going to try to color code it a little bit to make sure we have everything exactly how we need it, our different parts. You got that first part in blue, this part which I'll put in, let's see if I can do green, and then we'll leave that divided by delta x in yellow. Okay, so what I'm going to do from here is just to plug in certain values. So I'll go down here. So we're still taking a limit. For the part in blue, all I'm doing, I'm taking this function, everywhere that I see an x, I'm now plugging in this x plus delta x. So it's 4 times not x squared, but now x plus delta x squared. Minus 41, not just x, but x plus delta x. And then minus 14. That's the entire function replacing x with delta x. They now want you to subtract f of x. Well, f of x is just what's up there, 4x squared minus 41x minus 14. And then all that is divided by still delta x. All we're doing from here is just going to try to simplify a little bit. And to simplify this, it means just to kind of, FOIL some things out. So, still the limit as delta x approaches 0. This part will be now 4 when I expand this. X plus delta x squared, again, means x plus delta x times x plus delta x. So you'll get x squared plus an x delta x plus another x delta x plus delta x squared. Okay, let's expand this through, distribute the 41 through. So negative 41x, negative 41 delta x, and then minus 14. Then same thing here, I need to distribute this negative through to the whole part that's in green. So minus 4x squared, I'll add 41x, and I'll add 14. And remember, the key is that this part here in green should all eventually cancel out with something. So that's what we should be looking for. Okay, what I can look at though here real quick, I have these x delta x's, 2 of them, so that should be 2x delta x. That can just be a nice easy simplification. Okay, I'm also going to distribute this 4 through. Limit delta x approaches 0, so it's 4x squared plus 4 times 2, we give you 8x delta x, and then I'll have 4 delta x squared, so I got all this going through. The rest I'm just going to keep the same. Minus 41x, minus 41 delta x, minus 14, minus 4x squared, plus 41, 41x that should be, and then plus 14. All that is divided by delta x still. this is where things should get easy, because now you just want to look for things to cancel out. Again, all three of these guys should cancel out somewhere. Well, the minus 4x squared goes with the positive 4x squared, the 41x and the negative 41x, the 14 and a minus 14. So now from here, well, what should happen is I should have a delta x everywhere, and I do. So they should all cancel out. So a delta x goes there, one of the delta x's there, that delta x, and that delta x all go away. So what I'm left with, the limit as delta x approaches 0 of what's left? 8x plus 4 delta x minus 41. And now we plug in 0 for delta x, so I'm left with just 8x minus 41. That is your derivative, 8x minus 41. Let's do the same for the second problem. This one's going to be a little bit easier actually. Okay, we start the exact same way though, that the derivative will equal the limit as delta x approaches 0, f of x plus delta x minus f of x all over delta x. And again, can't use the shortcut, but I should know by using the shortcut, bring the 2 in front, 2 times 5 is 10. It'll become x to the not second but the first power. This is a constant, so it's already done. So 10x should be the answer I get. If I go back to this other one, if I'd use the shortcut, 2 times 4 is 8, so 8x, and then this will be is minus 41, the x goes away, and then the minus 14 is a constant, so it should be done. So look, I got the exact same thing for my answer as I should have. So let's look at this one now and say I need to get 10x as my answer. Let's see if I can do it. So, limit as delta x approaches 0. I'm going to plug in x plus delta x into this equation. So that's just your function, now plugging in x plus delta x. But now I need to subtract the entire f of x. So subtract 5x squared plus 8. So this is subtracting that entire second function. Okay, oops. And I'm going to still divide by my delta x. From here I'm just going to try to, again, simplify the top and expand it as much as possible. So to do that, this x plus delta x squared, like we did in the last problem, it'll be x squared plus, you get 2x delta x plus delta x squared. You have a plus 8, and I'm going to distribute this negative through to get minus 5x squared and minus 8. Again, all over delta x. If you can combine steps, then go right ahead and do it. Distribute the 5 through, 5x squared plus 10x delta x plus 5 delta x squared. Keep the rest of it there. Still divided by delta x. What you should notice as you're going through, especially if you know what the answer is, you should probably see a 10x coming up somewhere. Well, look, there he is right there. Now let's see if everything cancels out how it should. I have a 5x squared and a minus 5x squared. I have the positive 8 and the negative 8. So these two parts on the end canceled like they were supposed to. I now am supposed to have a delta x everywhere, and I do. So 1 goes away everywhere. So that leaves me with the limit as delta x goes to 0 of 10x plus 5 delta x. And again, I plug in 0 now for delta x. Now that things have canceled, I can plug in 0 for my limit value, which leaves me with just 10x as my answer, just like that. Okay? Now, moving on to these ones. Find the equation of a tangent line to the function at a given point. These ones you're allowed to use the shortcut. So, here are your two problems, and here's how we're going to hash them out. First, we need to find the derivative. Okay? To find the derivative, bring the power in front. 2 times 2 is 4. We bring the power down by 1. It was x squared, so now it's just x. This one was x to the first power, so I just subtract or get rid of the x from it, leaving just the coefficient negative 4. I want to know what the slope is at a particular point when x is 2. Well, that just means plug in 2, and I'm going to get a slope. Remember, derivative means slope. The slope is 4. From here, all I have to do now is think of y equals mx plus b and plug in the values I know. Well, my y value is 5. My slope is 4. My x value is 2. I need to solve for b. Well, 2 times 4 is 8. Subtract that over and I'll get negative 3 is equal to b. So that means that my final answer here is going to be y equals m, which is 4 times x, plus b, 4x minus 3. Same idea with this problem over here. To find the derivative, f prime of x, bring the 3 in front, gives me a 12. It'll now be x to the second power. I just reduced the power by 1. This one is x to the first power, so it'll be 8. Technically, it would be x to the 0 when I lower the exponent by 1. But remember, anything to the 0 power is just 1, so I can just get rid of that. So 12x squared plus 8. I need to know what the derivative value is at negative 1. So when I plug in negative 1, excuse me, I will get 12 times negative 1 squared plus 8. Well, negative 1 squared is 1. 12 times 1 is 1. 12 plus 8 is 20. So again, that is your slope. So we go through the same process. Y equals mx plus b. Plug in what I know. My y value is negative 4. My slope is 20. My x is negative 1 plus b. So that's a negative 20. I'll add 20 to both sides to get 16 is equal to b. So my final answer is, again, y equals the slope 20x plus 16 is the final answer. Make sure you put it back into this form. I've seen lots of times when people do not put it back into the actual equation of the line. Okay, and the last section, just matching a graph to its derivative. Derivative, again, means slope. Cannot emphasize that enough. So what I'm looking at here, the slope of this line, as I'm going right here, the slope of this graph right here is negative. The slope as I start going back up this way in pink is positive. So I need something that has a negative value slope and then slightly changes eventually to a positive slope. Right here in the middle, well, this slope right here would be 0. So it needs to hit 0 right in the middle. So which one of these goes from negative to positive, hitting 0? This guy right here, negative, 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 all of a sudden it changes to positive, hitting 0 in between. Looking at number 10, when you look at this guy, the slope of this guy is always positive. Okay? It looks like it has a slope that's much bigger at the beginning, though, than it is at the end. But it is always positive. So what guy has a big value early and then slightly calms down, but is always staying positive? That's this guy right here. So it's starting actually almost at infinity, and then getting more and more of a, well, less positive number, but it is still always positive. So that's why B is the answer for this one. C was the answer for the first one. Okay, in number 11, it's an absolute value problem. Okay, in the first part here, it's going downhill. So I should have a negative slope, and then eventually it is changing into a uphill, oops, I wanted that purple, uphill, a positive slope. So which one has a consistent negative slope? Because this looks like it's always probably positive 2, and then on this side negative 2 for a slope. Well, here's a derivative who has negative 2 early, and then it switches over to positive 2. So your answer here is letter D. So that means obviously by process of elimination, this last guy should be letter A, but why is that? Well, this line right here has a slope, it looks like a slope of just positive 1, and then it changes to this guy here, this part, which has a slope of 0. Well, look at this. In the second part, it's right on that axis. That's a value of 0, whereas the first part over here had a value of 1. So mainly what you're looking at here, you're judging the slope of the part on the left versus the actual function value or the actual y value for the part on the right. If you can do that, then it shouldn't be too much difficulty. The main part I'm looking at is, okay, negative to positive. Another thing you can do to help, and if this confuses you, then stop the video right now, but just look at number 9, for example. The function there, it's a quadratic, so the function is x squared. Use the shortcut. What kind of function am I going to get for the derivative? Well, it would be like, 2x, right? I would bring the 2 in front, and the x would be what's left. This should be a linear function, a line. Well, look at this. This is a line that has a slope of 2 crossing at the origin, at 0. So use that to help you for ones, especially if you get like a quadratic or a cubic. If you got a cubic, its derivative would be 3x squared. So if you had something that looked like this at the beginning, you should probably get its derivative looks like a u. Okay, so that's actually kind of a bit of a flash forward, but it can also help you for this test. So again, if that helps, great. If not, ignore what I just said. No matter what though, best of luck.